Hey everyone. One of the most common mistakes that gets made by students during Unit 2 is when we're dealing with something called nuclear symbol. Now below I've given you guys an example of nuclear symbol, and this is my friend named carbon-14. Now carbon-14 is one of the isotopes of carbon, meaning it's one of the versions of carbon that's out there. Now it has certain things that are in common with all carbon atoms, like having 6 protons, but it has a different number of neutrons than most carbon atoms do, and that's why we call it an isotope. Now I want to break down what all the things inside of this box tell us about carbon-14. Now the first thing that I'm going to show you guys is the fact that we can tell it's carbon from having our symbol right here. This symbol tells us that it's carbon. You can find this on the periodic table. It changes with whatever element you're dealing with, but this specific one, we're dealing with carbon. Now down here in the lower left-hand corner, you guys will find a 6. This is what we call the atomic number, and it tells us how many protons we are dealing with. So this is our number of protons. And once again, number of protons tells us the number of protons not just in this atom of carbon, but every single atom of carbon is going to have 6 protons in common. So that's the lower left-hand corner. In the upper right-hand corner, which you guys are going to see right here, we refer to this thing as the mass number. Now the mass number is not as easy as the atomic number, which is just the number of protons. The mass number actually tells us something different, and the mass number is going to be our number of protons, our number of P+, plus our number of neutrons. And that's going to equal the number that you see right here in the upper left-hand corner. So in this case, my protons plus my neutrons is going to equal 14. Now I can quickly solve this to figure out how many neutrons I have. So down here I figured out, okay, my atomic number tells me I have 6 electrons to work with. So I wind up with 6 plus the number of neutrons is equal to 14. And if we do a little math, you guys can quickly figure out that the number of neutrons is going to be equal to 8. So this atom right here, assuming it's a balanced atom of carbon, because I don't see that I have any charges being present, a charge would appear right there. This element, or this isotope, sorry, of carbon has 6 protons, which we found using the atomic number. It has 8 neutrons, which we found using the mass number, and it also has 6 electrons, which you can tell because it has the same number of electrons as protons because there's no charge present. Now, just to make sure that you guys have it, I want to introduce you guys to lithium-7. Lithium-7, we can break this one down in the exact same way. The first thing you guys will notice that it is in fact an element of lithium. And so you will find this on the periodic table. It's in the first column of the periodic table, or what we call the alkali metals. And lithium has a total number of protons that is 3. And once again, this is what we call our atomic number, and it's the number of protons. And then in the upper left-hand corner, you guys will see that we have a mass number of 7. So this is our mass number, and this tells us our protons plus our neutrons. So if we're going to do the math again, we take our atomic number, which is 3, and we're going to add something to 3 to make it equal to 7. In this case, n is going to equal 4. And I'll go ahead and circle that in a different color so it stands out nicely. So our number of neutrons is 4. Once again, we do not have a charge present on the atom. So what we're dealing with in this specific isotope of lithium-7 is that we have 3 protons, we have 4 neutrons, and we have 3 electrons. So I hope that helps you guys out with this idea of nuclear symbol. If you need any help, I would suggest watching the video over again and seeing if you can solve any of the examples before I give you guys the answer.